Our usual number system is based on the number 10, and what this means is that place values, when we write numbers, really designate successive powers of 10. So we have, reading from the right, ones, tens, hundreds, thousands, and so on. So when we see the number 4275, what this really means is we have 4 thousands, 2 hundreds, 7 tens, and 5 ones all added up. Now, just because the usual way that we do it is based on the number 10 does not mean that we cannot base it on other numbers. And in particular, the binary number system is a number system which is based on the number 2. So instead of having 10 numerals, which we have in the ordinary number system, we need only 2 numerals in the binary number system, and those numerals are 0 and 1. And the reason that the binary number system is common when using computers is that electronic circuits can easily interpret the switch settings on and off as a 1 and a 0. However, since there are only 2 numerals available in binary, that means that more digits must be used in order to represent a given number. And generally speaking, about 3 times as many binary digits are needed as decimal digits. Okay, so for example, we have the number 101001 in binary. Okay, so what does this binary number represent? Well, we have 1 unit, and this would represent 2s, 4s, 8s, 16s, and 32s. So that means we have 32 plus 8 plus 1, or 41 in decimal. Now, binary digits are also known as bits, and the rightmost bit in a binary number is known as the least significant bit, or LSB, and the leftmost bit is the most significant bit, or MSB. And so the next thing is, how do we do these conversions? If we want to convert a decimal number to binary by hand, then what we do is divide the number by 2 repeatedly, keeping the remainders, which will be either 1 or 0, and we write those from the right. Okay, so we repeat the operation, keep dividing by 2, and writing the remainders right to left, and then the final bit will always be a 1. Okay, so for example, we need to convert 87 in base 10 to binary. Okay, so 87, divide that by 2, and we get 43 with a remainder 1. Okay, and so then we need to divide 43 by 2, and we get 21 with a remainder 1. Then we need to divide 21 by 2, we get 10, remainder 1. And then we need to divide 10 by 2, we get 5, remainder 0. And then we divide 5 by 2, we get 2, remainder 1. And then finally, we divide 2 by 2, and we get 1. Remainder 0. Okay, and then our final bit is going to be 1. Okay, so then writing these remainders right to left, we have 1, 1, 1, 0, 1, 0, and then the most significant bit is always 1. So there it is, 1, 0, 1, 0, 1, 1, 1. And just as a check, we could go ahead and add up all of these various powers of 2 to be sure that the answer is 87. See, this is 1, 2, 4, no 8, and we have 16, no 32, and then 64. So we have 64 plus 16 plus 4 plus 2 plus 1, and the answer is 87. So that gives us a little check.